Now, as per the syllabus, we have to make a comparison of the Otto, diesel and the dual combustion cycle, which we have now studied, the PV as well as the TS diagrams. But before that, let us have a look at air standard efficiency. Air standard cycle we have just covered on the previous board. Let us look at the air standard efficiency. The air standard efficiency is basically done to compare the effects of different cycles. It is important that the effect of calorific value of the fuel is totally eliminated, as we had discussed in the previous board. In air standard efficiency, we don't take the calorific value of the fuel. It's not considered, it's assumption, one of the assumptions we have made. This is achieved by considering air assumed as a perfect gas. In the assumptions, this was also mentioned as the working substance in an engine cylinder. So, the efficiency of the engine using air as a working medium is called the air standard efficiency. This is all for analysis purpose. This is all theoretical. It's not practical. You don't have this. And practical applications in vehicles or whatever, let's say, equipment you have to use, whatever contraption. Must remember that the actual efficiency of any engine will always be less than the air standard efficiency. So this is somewhat standard, means theoretical standard, perfect, near perfect efficiency under ideal conditions. This can be understood by the term relative efficiency. This relative you must have studied a lot in the earlier semesters. So as far as efficiency also is concerned, relative, it is nothing but the actual thermal efficiency of that particular cycle compared to the air standard efficiency. It will always be less than 1. Now we come to the comparison of the Otto, diesel and dual combustion cycles. Dual combustion cycles. Introduction. To make a comparison, it is important that variable factors are used as a basis for comparison of cycles. What are these bases which are used? We generally take, out of the ones which I am going to mention, we take 2 of them and then we compare all the 3 cycles. What are they? What are the various variable factors? Compression ratio, the peak pressure, heat addition, heat rejection and net work. Out of these 5 of them, we will take 2 and then take any 2 and then compare for all the 3 cycles of Otto, diesel and dual combustion. Excuse me. Some of the variable factors must be fixed, as I mentioned. This analysis, once we do the analysis, this will show, once we do this analysis, taking 2 factors, any of these 2, it will show which cycle is more efficient for a given set of operating conditions. We will take 2 operating conditions and then see for all these 3 cycles which is more efficient. So there are 4 cases we will study. 4 cases in fact. Let us come to the case 1. In case 1, as I said, we will take 2 variables. All the 3 engines, this is for analysis purposes, all the 3 engines will have the same CR and heat addition, same compression ratio and heat addition. Let us see. Now, this is what is the Otto cycle 1, 2, 3, 4, 1. Constant volume. Diesel is at constant pressure. 1, 2, 3 dash, 4 dash, 1. What is the dual, which we've seen in the previous, on the reverse of this? 1, dual combustion cycle, 1, 2, 2 dash, 3 dash, 4 dash, 1. 1, 2, 2 dash, 2, 2 dash, 3 double dash, 4 double dash, 1. This is the petrol part, the diesel part. This we have covered. Now, from the TS diagram, heat input, let us first examine the heat input. Now, what is the heat input for all the three cycles? For the petrol Otto cycle, the heat input is 5, 2, 3, 6. Temperature and entropy, the area inside the curve is the heat input. You know this. For diesel, it is 5, 2, 3 dash, 6 dash. Now all these three areas are equal, which I am showing to you. For the dual combustion, 5, 2, 2 dash, 3 dash, 6 dash. These three areas which I have mentioned, all the three areas are equal. This is the actual analysis carried out in the laboratory, and we get this graph. So we see from the temperature entropy diagram, all the heat inputs are the same. Next we see that all the cycles start from 1 to 2. That is as the CR is the same. This 1 to 2 is common for all the three cycles. That is the Otto, diesel and dual combustion. Because the CR is the same. So let us look at the TS diagram for the same heat input. For the same heat input, the heat rejection of Otto cycle is 5, 1, 4, 6. This is the smallest. Minimum. For the diesel cycle, the heat rejection is 5, 1, 4 dash, 6 dash, which is more than the petrol for the Otto cycle. And for the dual, it is in between. It is 5, 1, 4 dash, 6 dash. So what inference we draw from this? You see that the Otto cycle heat rejection is the minimum, and as well as considering this, the Otto has the highest work output and efficiency. The diesel has the least efficiency, and the dual combustion cycle has an efficiency which falls in between the two. This is the inference we have drawn from these two, PV and temperature entropy diagrams. Now this is the case 1. Keep a note, the highest efficiency was that of the petrol. The diesel had the least and the dual combustion had the efficiency in between. Next lecture we'll come to the case 2, in which we will take two more variables. We will take two variables and then again compare the 3 cycles. Thank you.